Hi, welcome again, and I find this humorous series in which we try together to understand the molecular level of bone. In the last video we had summarized antibiotics, so we're gonna go through anti-resorptive drugs, which are bisphosphonate, calcitonin, vitamin D, and estrogen. But before we discuss that, we have to understand a few highlights about the structure of our own bone and how our body regulates calcium level, which are highly required for bone formation, mineralization, and remodeling. Our bone has a cortex and a medulla. A bone cortex is more likely similar to the building structure, like house. So what I mean that we all know that the main building material are steel rods and cement and bricks blocks. So the same here in our bone, that we have collagen fiber similar as steel rods, and we have calcium and phosphorus, the mineral component similar to cement, and we have a bone matrix protein as bricks blocks. So if there is a defect in the collagen fiber, that will be represented by osteogenic imperfecta, and if we had a defect in the mineral component, that will be manifested as rickets in children and osteomalacia in adults. And if the defect in the bone matrix protein may end up to osteoporosis. Actually, in osteoporosis there are many complicated details about post-physiology fat, but in simple way, in patients with nutritional problems like marasmus or kwashiorkor, there is not enough protein in the body for metabolism. So the body reacts to that by metabolize the protein in the muscle within the protein in the bone matrix. So if you had a very beautiful house like that, so that house will need for routine maintenance to keep it beautiful and strong for a long time. And as you know, any biological product has a production date and expiry date. So the same here with the body cells. Our body cells have meiosis as a production date and apoptosis as an expiry date. And between meiosis and apoptosis, the cells are fully functioning and very active. In bone cells, the main aim for this process, which like maintenance, is to routinely renew the mineral component of bone cortex. So we look at these guys who will make a maintenance for your house. We have in cells in bone, osteoclast and osteoblast. In the site we can see that this guy is osteoclast and this guy is osteoblast. So in the medulla bone we have a bone marrow which contain 1 billion of progenitor stem cells. Osteoblasts are developed from stromal mesenchymal stem cells, but osteoclasts developed from hematopoietic stem cells. Here in osteoclasts, we can know the function of osteoclast that removes the old expired bone and release calcium and phosphorus. But the question is, which type of calcium that osteoclast remove it? There are two types of calcium in bone: rapidly mobilized calcium, which presents an interstitial fluid, and gradually mobilized calcium, which is deposited into type 1 collagen. Actually, osteoclasts act on this gradually mobilized calcium by digesting collagen and releasing calcium, phosphorus, and hydroxyproline. So that is the bone, and this is a calcium deposited in bone collagen type 1, and this is the osteoclast layover and bind to the edges of bone by this green integrins. And inside the osteoclast you can see carbon dioxide react with water in the presence of carbonic anhydrase 2 which result in hydrogen ion and bicarbonate, and bicarbonate activate this bicarbonate chloride exchanger, which get the bicarbonate outside the osteoclast and makes the chloride coming inside the osteoclast, and then chloride pass through this chloride channel into lacking space, and hydrogen ion pass by this transporter in this space. So we have hydrogen and chloride, which generate an acidic media in this lacking space, which is required for lysosomal enzyme to work. A lysosomal enzyme is secreted by the osteoclast by collagenase enzyme and the protease enzyme to digest the collagen and release the calcium and phosphorus and hydroxyproline. So here we can see the osteoblast, and we see before that osteoblasts store and deposit calcium and phosphorus for bone formation. And so how osteoblasts make that? Normally in a bone matrix, inorganic calcium bind to inorganic phosphorus to form calcium phosphorus complex. So if we store inorganic calcium with inorganic phosphorus inside the osteoblast, that will lead to calcification of osteoblasts and eventually cell death. So osteoblasts make a trick, get inorganic calcium from the blood inside the osteoblast, this blue dot, and this pink dot is an organic phosphorus, but the osteoblasts convert inorganic phosphorus into organic phosphorus by reaction inside it, energy required reaction in presence of phosphoethanolamine kinase to form phosphosanolamine, which is organic form of the phosphorus, and stored both of them, inorganic calcium and organic phosphorus, inside a vesicle. So how osteoblasts deposit calcium phosphorus complex into bone matrix, as this vesicle come close to the cell membrane of osteoblast and rupture, endocytosis happen and rupture is content out. We have now inorganic calcium and organic phosphorus, but we need to return back organic phosphorus to inorganic phosphorus. So the osteoblast secrete a cytoplasmic enzyme called the alkaline phosphatase enzyme, which converted into inorganic phosphorus and bind to inorganic calcium and make calcium phosphorus complex, which is deposited in the bone matrix. Now we're going to discuss the regulation of calcium and phosphorus level in the body. So we have two triad. So we have here two triad about the main hormones and the body systems that are mainly responsible for calcium homeostasis. And the body system are gastrointestinal tract, which you take care of absorption of calcium, and kidney renal system, which you control over excretion and reabsorption of calcium, and the bone act like a bank where the body stores its own calcium. And regarding the masters hormones, we also have another triad. First of all is parathyroid hormone, which is secreted by the chief cells of parathyroid, and the active form of vitamin D, which is activated by the plasma converted tubule in the kidney, and the calcitonin, which is secreted by the parafollicular cells of thyroid gland. We also have to know that acid-base balance have a direct effect on ionized calcium level, as acidosis increase ionized calcium and alkalosis decrease ionized calcium. I just mentioned that acidosis and alkalosis affect directly ionized calcium. So what does it mean? That we have ionized and non-ionized calcium? Yeah, for sure we do. We're gonna figure out that blood calcium is divided half and half, 50% ionized calcium and 50% non-ionized calcium. However, it is more deeply classified that based on filtration through the kidney. We have non-filterable and ultra-filterable. Non-filterable is a 40%, and that one cannot be filtered through the kidney, as they bind to plasma proteins which have large molecular size that cannot pass through the filtration pores. Regard the ultrafiltrable type, 60% is 50% free ionized calcium and 10% calcium ion complex. So we can say that 10% is 40% is 50% of non-ionized calcium. The function of calcium in the body is very important for contractility of the muscles, the neurotransmitter release and coagulation cascade and hormone release from the glands. But the important is that all this function mediated by ionized calcium. So now we have here a story that perhaps make it easy to memorize how the body regulates calcium and phosphorus level by the previously mentioned hormone in the body system. Here is the college, and the college told this student that he has to pay for his tuition fees. The student became confused and sad as he needed money for this tuition fees. So he went to his bank where he stored his own money, and he used ATM bank. But he is still confused and sad because that money is not enough. So he sent a text to his parents asking for more money, and he also decided to reduce wasting his money on fast food. So we can say that campus is our body, and this money is the calcium and phosphorus, and these students we can say is hormones like parathyroid hormone and calcitonin. And here this bank is our bone where we store our calcium and phosphorus, and the ATM is similar to osteoclast. And ATM is like osteoclast. And the student sent active vitamin D to his parent or his GIT system to increase absorption of calcium. And he also, the parathyroid hormone act on the kidney to decrease the excretion of calcium and the reabsorption of calcium and phosphorus. We're gonna go through more details in our next video. See you later.